Right, so this is going to be objective 27. We are going to describe in behavior of polynomial functions. I think this is going to be really easy for you. When looking at this in our textbook and when looking at this with different concepts and units online, they cover in behavior and domain and range and increasing and decreasing intervals all within one lesson. And I feel like if I do that, then that is going to confuse you. So what I've chosen to do is break it apart and do one little section at a time. So because we're only covering this one little section, I feel like it's going to be very easy for you today. We will finish the notes, we will do a little bit of practice out of the book, and then you will even take a quiz before you leave here. And then even after that, we should have extra time to go ahead and take a look at some of the practice items online, because the question came in second block today was, how are they going to ask us this type of question on the SOL? So I went ahead and we pulled up TestNav 8 and just kind of peeked at some of the questions to kind of let you see how certain questions are going to be being asked. So we're just going to peek at those and talk about those a little bit today. So first things first is we're going to talk about degrees of polynomial functions. And we talked about this a little bit the other day. We said that every time you add on a degree, what happens to the graph? It takes another turn. Okay, it's going to take another turn. So, and these are specifically today just polynomial functions, okay? X to the first power, x to the second power, x to the third power, x to the fourth power, polynomial functions, not rational functions, not absolute value functions, not exponential or logarithmic functions. We're just talking about polynomial functions. So, if it has a degree of 1, what will it look like? It'll only be going in one direction. It will be a linear function. If it has a degree of 2, what happens? It'll be a parabola, but as far as our directions go, it'll go up 1 and down 2. Or it could reverse and it could go down 1 and up 2. Okay, but it'll make 2 different direction changes. If it's x to the third, it will go up 1, down 2, up 3. So what I would like for you to do right now is take a minute and draw x to the fourth, x to the fifth, and x to the sixth. So if we drew a fourth degree function, what would it look like? An M or a W. So it could go 1, 1, 2, 3, 4. Something like that. Okay, the M is fine too. Okay, so you can start it going negative first if you'd like to. Okay, if it's to the fifth power, it's going to go 1, 2, 3, 4, 5. And if it's to the sixth power, it's going to go 1, 2, 3, 4, 5, 6. Any questions? For every degree you add on, the graph will take a turn. Okay? So what we're going to talk about today is we're going to talk about in behavior. Okay? In behavior. The in behavior is the behavior of the graph f at x as x approaches positive infinity or x approaches negative infinity. And you can denote the symbols there where it has the x with the arrow to infinity. That means as x goes to positive infinity. So here's what's going to happen. As x goes to positive infinity, you have to understand direction, okay? If x is traveling to positive infinity, which way does x run? Do your x coordinates run? Right and left. So if I'm traveling to positive infinity, what direction am I traveling? So here's what it's going to say. As you go to the right, and you're going to look at the far right of your graph, you are going to tell me what happens to the y. Does that make sense? If the y is going up, where's the y going? To positive infinity. If y is going down, it is going to negative infinity. And then you're going to reverse it. As x approaches negative infinity, so x is going negative, what direction is he going? We're going to the left. Again, you're going to tell me what happens to the y. So as we go to the right side of the graph to positive infinity, what happens? And as we go to the left side of the graph, what happens to the y-coordinate? Okay? We'll put that into action in a minute. The second thing we're going to talk about is odd or even degree functions. Odd degree functions will always have an odd number of zeros. Even degree functions will always have an even number of zeros or no real zeros at all. So let's just look. These won't be numbered examples, but let's just look at a couple examples for this. So give me an odd degree function. Something that's to the odd power. 3, x cubed. So if we look at an x cubed function, how many zeros does this have? What's a zero? Where it crosses the x-axis. Now I know we talked about, last time we talked about zeros, what did we talk about zeros with? Our quadratic equations. We looked at parabolas and zeros. But I'm going to tell you right now, you can find zeros with any type of function. You can find zeros with cubic functions and fourth degree functions and linear functions. Any type of function can have a zero as long as it's crossing the x-axis. Zeros, x-intercepts, solutions, roots, they're all where it crosses the x-axis. So this has 1, 0. So does that make sense? It's an odd degree function. It will have an odd number of zeros. It could look like this. 1, 2, 3, like so. How many zeros are there? 1, 2, 3. 3 zeros. It still, though, has an odd number of zeros. Does that make sense? Odd degree functions will have an odd number of zeros. Okay? Even degree, give me an example of an even degree function. 4. So 1, 2, 3, 4. How many zeros are there? 1, 2, 3, 4. So it will have an even number of zeros. It could, though, look like this. 1, 2, 3, 4. How many zeros? None. So it's either going to have an even amount or it's going to have none. It could look like this. 1, 2, I drew that. Not good. 1, 2, 3, 4. Like so. Okay. How many zeros? 2. So even though it's a fourth degree function, it could have 4 zeros, 2 zeros, or no zeros. But either it's going to be even or none. Any questions on that? Um, it could, because we look at it with quadratic functions. But for today, it's going to, when we're just looking at um, in general, does that make sense? It should have, even functions should have an even number or none. Okay, just in general with what we're looking at today. Okay. So here's what we're going to do. This is how we're going to apply it. This is how the examples in your textbook are going to look, and this is how your quiz is going to look. So I put it all in the same format so you wouldn't be confused by it. Okay. Number one, we are going to determine the end behavior. Number two, we're going to discuss whether it has an odd or even function. And we are going to state the real number of zeros. Okay, the real number of zeros. So we're going to look at a linear function first. So I'll give you a minute to write that down, and then we'll discuss it. Say it again. It is 1, 2, 3. Okay, so this is how we're going to discuss our end behavior. You're going to start by saying, as x goes to positive infinity, and this is for every single problem, okay? Every single problem is going to be set up like what's on my whiteboard right here. As x goes to positive infinity, y goes to blank. And then as x goes to negative infinity, y goes to blank. So as you travel to the right, what happens to the y? As you travel to the left, negative infinity, what happens to the y? Does that make sense? So you could fill this in on every problem, and then all you have to do is fill in the blank. Okay, that's where your answers are going to be. So it's going to say, as x goes to positive infinity. So what direction is that? To the right. So let's go to the far right of the graph. Now look, we are looking at the arrow, the far right of the graph. What is happening to the y? Are we traveling up or down? Down. So where's the y going? To a negative infinity. Okay? Then you're going to reverse it. As x goes to negative infinity, so as you travel to the left, okay, that's negative infinity on the x. Look at the arrow on the far left of the graph. Where's the arrow going? Y is traveling to positive infinity. Thumbs up if you understand that. Thumbs in the middle if you're kind of iffy. Thumbs down if you're like, you didn't get it at all. Okay. All right. Is this an odd function or an even function? Odd. It is because it's linear. And how many zeros are there? It only crosses the x-axis in one, so there's one real zero. Any questions on that? All right, example 2. As x goes to positive infinity. So what direction is that? To the right, so go to the right side of the graph. Look at your arrow on the right side of the graph. What's happening to the y? Y goes to positive infinity. Okay, then reverse it. as x goes to negative infinity. So what direction is that? To the left. Look at the arrow. Okay, because that's as far as we can see. I mean, it will be going to infinity, but go as far as we can see what's happening to the y. Y is going to positive infinity. Okay, thumbs up if you got it, thumbs in the middle. If you're still iffy, thumbs down if you don't understand it all. Thumbs up, thumbs down. Let me see where you're at. Okay, good. Odd or even? Even. How many zeros? 2 zeros. Easy. Second block said, and that's it. That's it for today. Okay, I just want to make sure you're good with this. So try this one on your own. See if you can get all the way there. All right, who would like to try? And read it to me. Chastity. What do you think? Agree or disagree? Agree, I do. As we go to the right, as x goes to positive, y goes to positive. So I'm going right and up, okay, which is positive and positive. As I go to the left, to negative infinity, the y is traveling down to negative infinity, okay? All right, odd or even? Odd, and how many zeros? 3. Are we okay? All right. All right, you try that one. 5 examples total today, so we're almost done. Bless you. All right, Shane, this one's for you. Okay? Agree or disagree? Agree. Very good. Odd or even? What do you know about the arrows for an odd versus an even? Okay, so if it's odd, one of the arrows will go down. They're opposite from each other because you go 1, 2. There's the only way to go the other way to get odd is to go back up. 3. Does that make sense? They'll go opposite. So instead of you counting 1, 2, 3, 4, 5, 6, like, what is that one? The eighth? Is that an eighth degree? Instead of you counting how many, just look at the arrows. So if it's even, they'll either both go down or they'll both go up. if it's even. So which one would this be? Even. Okay, if you were counting 1, 2, 3, 4, 5, 6, 7, 8. How many zeros? None. It does not cross at all. Okay? Well, it's not crossing the x-axis at all. Does that make sense? Okay. All right, last one. All right. All right, here we go. All right. As x goes to positive infinity, y goes to positive infinity. Good, Jenna. As x goes to negative infinity, y goes to positive infinity. Everybody good? Odd or even? Even. Does it help with the arrows? Just if they're both going the same direction, it's even. Odd is opposite. Okay. How many zeros? 2. All right. So a little bit of practice, and then when we get back from lunch, we will take a quiz. Okay.